Okay, so let's go through this. This is the study guide we've put together for our final exam. So I'm just going to kind of go through, just walk through this. So obviously, this is on Google Plus as a document, but I also want to do a quick recording of it as well. So the things you're going to want to know. This is, as I said, the final exam will be. We'll cover points we've talked about over the course of the term. Not necessarily in as much detail as we, but these are the key high level points that you're going to want to make sure you understand going into the exam. Okay, so the first one we talked about, the MIS infrastructure. The four components. They are hardware, software, data, and network. And kind of what the relationship between, kind of what they are, and how they work together. All right, so the idea of how does the relationship between hardware and software, how they interact with data, and then how network is used. We talked a bit about Porter. So the thing you want to go back and take a look at is what we talked about with the value chain model, which is really the model through, it's the model that we see implemented through ERP implementations. So the idea of, you restructuring your organization around this idea of a value chain of, a core operational components that, are always focused on, as you go through this chain, you're adding value or incrementally adding value to the product that is going out, and then all of structuring all of the other pieces of the organization as supporting organizations. So things like human resources and purchasing and accounting become the supporting organizations as opposed to being directly in the value chain. You want to know, go back and review, the core systems, the core enterprise applications we talked about. So ERP systems, which do the core business, we basically handle core business processes. Supply chain management systems, which are dealing with the relationship between the organization's value chains and the value chains of the suppliers. The CRM, which deals with the relationship between the organization's value chains and the value chains of the customers. Right? So SCM is pointing backwards, CRM is pointing forwards. Talking about decision support systems, different ways of analyzing data, different tools to be able to analyze and do reporting and querying and different types of things of that nature. And then finally, enterprise information systems, executive information systems, which are around focused on executive reporting, dashboards, things of that nature. I want to go back and review the difference between OLAP and OLTP. Online transaction processing is really what ERP, SCM, and CRM systems do, specifically designed to execute transactions, around business processes. Analytic OLAP is designed to analyze large amounts of data, be able to do different types of analysis on that type of data. The idea is the OLTP is usually the generation of data, focused on the generation of data through the execution of processes, and online analytic systems are really taking that information and then kind of being able to do analysis to gain insights and understanding. We go back, take a look at business process reengineering, some of the issues around that. So the restructuring of businesses, and business processes to achieve optimized structure. The ERP systems, basically, BPR is not necessarily the relationship between BPR and ERP is that the implementation of a redesigned business process a lot of times is achieved through the implementation of an ERP system. They become very difficult because it's really dealing with change, organizational change, and changing the way people operate. So those that actually was discovered as really one of the key things that drive both the cost and the challenges of organizations making these types of things, because you're really fundamentally redoing the way the business operates. You want to go back, take a look at the history of the internet, and what's the difference between the internet and the World Wide Web. The internet is really the plumbing, the way uh, kind of a fundamental, you know, global communication network linking sites together. The World Wide Web sits on top of that and provides content. So we think of as the World Wide Web as, a lot of times we talk as the internet, but it's really the web is the thing. It is the most visible and most platform we interact with the most. Um, want to know what a business process is? The definition of a business process. Um, basically, a series of tasks with a expected outcome. Um, advantage, the challenges and implementations of these things. Once again, going back to kind of the similar to what we talked about, business process or engineering. The hard things dealing with this stuff is around changing work, changing the way people work. Restructuring organizations to align itself around a value chain model, things of that nature. Um, understand the costs and the challenges of organizations as they were implementing ERP systems. Um, there's a lot of different things that were involved driving the cost. So obviously there was the cost of the software, there was the cost of um the of consulting around the implementations of these things. There was the cost of developing and implementing new hardware to run these systems on. And then there was the cost to the organization. A lot of things were kind of unexpected around, basically, around restructuring. A lot of these things like adjustments to headcount, which has an impact, and again, they have a short-term impact around disruption to business processes as well. If we look at Hershey's, we look at some of the challenges they faced on their go live. They did a big bang approach, and really had some real challenges with the early days of their implementation, but had a material impact on the way their business was running. Want to go back to take a look at how a web server works. Basically, runs communicates through a browser, running on a machine, sending requests into a server, which then translates it and then returns a result back based upon what the request is based on. Go back and look at cloud computing, some of the stuff we talked about with cloud computing, some of the different implementations of cloud computing. It's basically delivery of, of computing resources across the internet. The different styles, the three major styles we see is infrastructure as a service, which is the delivery of basically virtual systems and storage across the internet. So Amazon Web Services is our best example of that. Software as a service is really running applications across the internet, which is best example. Salesforce.com was probably one of the better ones. There's SAP has some stuff. I think other organizations, Oracle has stuff now. Everybody's kind of got pieces of things that kind of run as applications running, accessible on the web and sold as a service. And then platform as a service, which is if you take infrastructure as a service and add specialized tools to it, basically, like if you go to AWS, you got Amazon Web Services, there are integration pieces, there are database pieces, which if you start using them, in fact, becomes your infrastructure as a service solution that now becomes a platform as a service. One of the difference between business continuity planning and disaster recovery. Business continuity planning is really the business impact, understanding what the business requirements are, what the implications of a disruption in business terms, and then accommodating that in terms of what how an organization needs to react and respond. Disaster recovery becomes more of the technical implementation of what gets done in the business continuity planning. So the two kind of work together. Understand some of the differences in some of the roles. So, some of the roles we talked about over the course of the term: CIO, Chief Information Officer, is the executive that's in charge of the information technology operations. IT infrastructure manager would be an individual who would be um, tasked with the installation and operation of the technology, the fundamental technology bits, hardware, software, uh, networking. And finally, enterprise architect. Our enterprise architect would be, the role of an individual who would be responsible for the technical planning and designing of the of all of the different components and how they all kind of fit together on an end-to-end basis. The differences between spreadsheets and databases, it's really databases are highly structured with very strong rules established of how data should be organized and structured. Where spreadsheets, you know, um, the rules are there are some rules, but not as strict. So you have a lot more flexibility on databases, but excuse me, a lot more flexibility with spreadsheets. Right? So you can kind of organize and do things basically in any which way. However, the ability to with databases, the strength of databases are you can uh, work with larger and larger and larger uh, sizes of data sets, and the rules can be applied across all those as opposed to with spreadsheets. Becomes a little bit unwieldy as you get into larger and larger. If you move from hundreds of records to thousands of records to hundreds of thousands of records to millions of records. Relationship between knowledge, information, and data. Data is collections of facts. Can be of facts and measures. Some are quantitative, some are qualitative. Um, Information is the kind of the transformation of data, the application of context to data to basically be able to translate raw data into or measurements and the stuff that um, decisions can be made and analysis can be made on information. All right, so the whole idea of data processing is you basically are taking data and turning it into information. Knowledge is another tier above information, where very specific very specific types of information become internalized and used within an organization. A lot of times knowledge has been kind of resonant in people's heads. So data and information have really been kind of the backbone of what we think of as information technology. A lot of knowledge is really still in kind of in people's heads, but the idea of somehow kind of getting, kind of continuing to the evolution of taking information to knowledge and somehow being able to move that into a machine environment is kind of what we're talking about with artificial intelligence and machine learning. So that's still an evolutionary thing. But this idea of the organization of data, information, and knowledge is a pyramid where data at the bottom, information in the middle, and knowledge on top. What the idea of big data, the definition of big data. Big data is larger and larger collections of data that are of the size that regular databases cannot hold them. It can make, your traditional relational database is not well designed to handle big data. And so we're talking where databases can handle millions of rows. Um, Big data is significantly larger than that. So we're talking about petabytes of data. Being able to analyze it and process it and turn it into information. So the idea of it just larger and larger, collections of sensor data. So things we talk about, like with the Internet of Things, being able to collect data from any number of sources, then be able to process it and analyze it. The difference between an internet, an intranet, and the extranet. So the internet is the the formal definition of the internet is the overall global um, network, public network that can be accessed, um, connecting really most everything, all locations together. An intranet is a protected domain, separated, basically a separation the of a portion of the network from the internet through the use of a firewall. All right, so the idea of an intranet is it works the same way as the internet, but except that access can be controlled and managed, and basically security can be applied. An extranet is really a kind of a shared space for multiple organizations or different parties can uh, have it in a secured area, but multiple parties can be accessing the data. Take a look at access. So some of the stuff we talked about with access, the idea of tables, relational databases, multiple tables. Table is constructed of both rows and columns. Um, every row has to have a key, or every table needs to have a key, which is made up of multiple fields, can be made up of one or many fields, at least one, with the proviso that it needs to be able to make each record, each row unique. Foreign key is a field that is used, between two tables. So basically, a key, two fields, a primary key and a foreign key, that can connect two tables together in a join. So if you have two tables, there's one field that they both have in common, um, that can be used to connect the two tables together. All right. We talked a bit about relational databases, types of integrity, data integrity. We have entity integrity, which means that every row is unique in the table. Every row has a unique key. And then referential integrity, which means every row is, every table, two tables in a relationship, the contents of the field that makes up the relationship, the primary and foreign keys, everything matches. So everything that's in one table is also resonant in the other. So there's not a situation where you have one table that has entries that are not reflected in the other table. That is an invalid. That would mean that it's an invalid database, or a broken database, as they would say. Expect to see, we're going to do some example queries again. So give you a table and some data and the results of the query. So we've done there's a couple of videos out there as well. I've put some stuff out there. We've had some experience with SimNet, some kind of, just want to go back over that again and just, be familiarized with some of the ways that stuff works. With chapter 4, which is one of the last two sections, this is deals with chapter 4 and chapter 9. I want to go back and review the differences between ethical and unethical versus legal and illegal as it relates to the use of information. This idea of, ethical relates to acceptable uses of, or defined uses of information, versus legal, which actually has an enforceable aspect to it. So it's possible to have something that's legal and being unethical. I mean, that's a possibility. Ideally, what you'd want to have is something that's both legal and ethical. You want to take a look at some of the traditional methods. We talked a little bit about this around intellectual property. So it's copyrights, trademarks, and patents, and the idea that they've been affected by the digitization of information. Copyrights, trademarks, and patents have been around since the 19th century, so they're fairly well-established means of protecting intellectual property. The challenge, though, as you digitize information, it actually becomes easier to copy and utilize material that has intellectual property associated with it. So that actually has become has been has been an issue. If anything, has actually become as enforcing it and trying to make things that are enforceable, in the face of kind of modern technology is a challenge. So you understand different types of e-policies. We talked about some of the e-policies, acceptable use policy. I think we had talked about that within chapter 4. We'll go back and kind of review some of the different types of e-policies and kind of what areas, domains they may cover. You want to go back and look at the different types of legislation. So we talked around some legal, some of the legal stuff. So things like Sarbanes-Oxley, um, HIPAA, for medical. Some of the older ones as well. Some of the other, some of the issues that are involved with that. The challenge is the fact that technology moves much faster than legislation, and it's difficult for legislation. Ideally, you'd like to have a legislative um, entity in play, something that dealt with that can regulate things in a legal fashion. The problem is that technology moves faster than the ability to to basically write laws that match up with that. So the different rates of this stuff is a challenge, and something that has to be kind of looked at and addressed. Talked a little bit about security, some of the different types of security. There's different types of hackers. So white hat, black hat, hacktivists, cyber terrorists, and some of the different types of security approaches that are used to provide protection. And the idea that people are the weakest link in security. I mean, you can write encryption, you can encrypt data, and basically make it undecipherable without a key. Um, that's relatively straight. That's pretty well established. People, on the other hand, are the far easier to manipulate and to uh, use as entryways in from a hacker's perspective. So that's something that education, understanding, things of that nature. But people have and probably will always be the weakest link in security. Take a look at on the slide deck. Talk a little about different types of technology approaches to protection, technology approaches to protection, how each one's can be used to help provide. And then with chapter 9, there's a couple pieces we talked about with SDLC, so the idea of software development. The major phases of a software development lifecycle. So planning, analysis, design, development, testing, implementation, and maintenance. So kind of that. This can be represented in a circle form, of these different major phases. All right. These can be represented the way they can actually be represented in different ways, different methodologies and characteristics, or ways that all these things are through the way a software development lifecycle is actually implemented. So we have things like, for example, waterfall, which is a traditional, um, you know, multi-phased uh, project in which each phase is completed before you move on to the next phase. Um, Actually, it's a traditional, it's pretty well established project management approach, been used extensively in software. The problem is, though, that software actually tends to be pretty complicated stuff, especially trying to identify requirements up front. It's one thing to be able to design the requirements for a bridge or a road or a building. A little more difficult to be able to identify all the different dimensions of a piece of software. All right, so sometimes even though waterfall has some advantages and has been used extensively, with software there are some challenges. So what we've seen is other types of methodology which have emerged, which have specific focuses on trying to improve on um, mitigating some of the issues you run into with software development. So the idea of agile, the ability to kind of do these things on an iterative basis, of closely aligning IT IT people, developers, designers, with the business people who really are providing the insight and the input into um, what needs to be developed or how something should work. Right? So the major ones: Agile, RUP, RAD, Extreme Programming. We kind of had talked a little bit about those. Just want to know kind of what those, some of the basic characteristics of some, primarily the difference between waterfall and agile, and then kind of what some of these other ones might be. Um, Also, around some of the stuff around project management, understanding, some of the challenges around projects, why projects can fail, the idea of, you know, project managers having to deal with the what we call the triple constraint, which is resources, time, and scope. The idea of, you know, projects are temporary entities, that have resources allocated to them, should be completed within a certain time to accomplish a certain amount of work, and then balancing all of those, uh, to execute, to basically deliver to a product at the end, is really, from a project manager's perspective, balancing and coordinating all of this stuff between resources and time and scope. And then some of the stuff, and finally, the last thing we talked about within Chapter 9 was simply some of the issues of dealing with outsourcing and some of the challenges with outsourcing projects and things like that. Um, you know, your organization should not outsource core um, business functionality or things that are really organizations leverage for their competitive advantage. It really, if you go back and kind of look at outsourcing as it relates back to Porter, it's those support functions that theoretically could be outsourced more readily than things that are connected into the value chain. So you've seen historically outsourcing of information technology, but you've also seen things like outsourcing of human resources or pieces of those different functions that are going out there. So the balance is really always a question of outsourcing of what should be maintained inside versus what can be outsourced to a another provider, and then managing that relationship on an ongoing basis. Okay, so that is pretty much everything we'll be talking about on the exam. Okay, thanks.